if you want to hand over to Dave to talk through a little bit of background of what happens with your reports after you've pressed the send button.
Thanks, Steve. Okay. One of the things I've become aware of, concerned about in recent times, is that everyone is well versed, has a good understanding of predictions, where they come from, and going out and making observations and then sending in reports. What is less well known is what happens thereafter, and the further down the stream you go, the less that people generally know what actually happens, and that's not a good position for us to be organisationally. We need to have a better understanding across the board about what happens in these processes. So my plan here is to go through how things are dealt with, and make various comments and illustrations along the way. First bit is when you make your observation, observers send their reports in to a regional coordinator. For Australia, that's effectively Steve Kerr, but Dave Galt does all the hard work. I think that's what Steve was effectively saying before. And hey, Steve or Dave, you can correct me if I've got this wrong, but the main role of the regional coordinator is to bring the observations together and prepare an event file. In that process, I'll come across any problems and communicate with the observers to resolve them. They'll add a post-diction observation there based on a prediction, and that's added as a quality control check to make sure that things are consistent with what we expect. Fit an ellipse to the observations if that's sensible. If there's a shape model or models available, do an initial fit to the shape model. If there's a double star analysis, to work through that analysis. And I have to say, Dave Galt is, of all the regional coordinators, Dave Galt is most on top of that. US, Europe, Japan, they're not comfortable with not understanding that process at all. If you've got a satellite involved or a potential satellite involved, there's an initial asteroid satellite analysis. And when when an event crosses multiple regions, such as US, Japan, US, Europe, and potentially Australia and US, and Australia, Japan, and Australia, Europe, then there's coordination between the coordinators to ensure that one of them has the complete set of data. And when they've got all that together and resolved any of the issues that they have concerns with, then they send the results to the global coordinator, who currently is me, and I ask them to come in batches of 10, so that it's a reasonable number to process without losing track of what's happening. So what happens when they go from the regional coordinator to myself and Dave Galt? I'm the orange box, Dave Galt's the yellow box. Effectively, what happens is a quality assurance process. The first step to do is a superficial overall check of the report. Does it superficially look okay? Because starting point is the regional coordinators will presumably have done a good job. No, they know what they're doing. So do we need to do a detailed check of that? Well, no, but the superficial overall check is worthwhile to see if something doesn't look right and then delve into that. Because the regional coordinators are not particularly expert in shape model fitting, double star solutions, or possible asteroid satellites, then that gets dealt with in detail at this level. I referred to in the previous thing, the obvious things with the number of chords looking a bit odd. Look at chord consistency issues, and if there's a major issue, which you sometimes see, then raise questions. Sometimes ask for light curves. Unistellar, they operate as a separate region themselves because it's a global community. They report to me separately, and I merge those in with the existing observations, either to add new events or to add events to existing observations. So the addition of unistellar observations either hits or misses with existing observations can improve the results. And when the observation looks like there may be a hidden problem, ask questions. And that's the bit where some people don't like having the questions asked. When that's all worked through, I'll add the event to our main file of observations. And then usually within about 3 months of the events, we'll get all the observations for a month will have come in. And at that point, Dave Galt goes through and reviews all the observations for that month to do a second quality assurance check. Dave is good at finding faults. He's quite good at telling me I'm wrong. And certainly with observations, I submit where I think it's, hey, I've got a good result here. Dave is very, very good and polite in telling me, hey, bullshit, Dave. And this is the type of environment we need to have. We aim to have the time frame from getting from the regional coordinator to me within 2 months of the observation is the desired time frame, which means time frame for making the observation to the regional coordinator. People would hopefully think in terms of days rather than many weeks or months. One of the issues that particularly concerns me, and I've come across it too often over the years, is when people delay sending their results in, and by the time it gets independently looked at, person says, oh, there's something funny here, and goes back to the observer. Well, the event is no longer fresh in their mind, and some of the relevant issues have been forgotten, in effect. My view is getting the observation from the observer into the processing pipeline should be done as soon as possible, not wait until next week or next month. And then the regional people aim to get the results to me within 2 months of the observation. Now, having got that in the file, and you've all presumably aware that we have this massive file of all of our observations, well, what then? What actually happens? Do we just put in our bottom drawer and do nothing? Or do we actually try to promote our results in some manner? And what actually happens with the data? Right, size and shape of asteroids. That was the original motivator for doing the occultations. So go back to the 80s, the size of asteroids were pretty much unknown. Very strong driver back then to do occultations to measure their size and shape. For that purpose, multi-chord events are required, which is why most of the observations in the 80s and 90s have multiple observers. It was what they were trying to achieve. When you've got a good set of observations for an event, hey, you got something to work with. But there's a huge limitation with occultations, and that's you only get a single profile of the asteroid. It's particular orientation at the time of the occultation. And most asteroids have significant irregularities. Some of them can be quite huge. Some of them can be elongate so that they appear much larger in one orientation than another. And you don't see that by looking at a single occultation profile. However, when you combine our occultation results with shape models, we can derive very good diameters. Shape models derived by light curve analysis, rotational light curve analysis, largely done by amateurs, but professionals as well. Shape models provide a shape, but absolutely no scale. It's scale independent. With the shape model, you take your occultation chords and you size everything so that the occultation chords match the size or match the profile of the asteroid in shape model. And then from that matching, you can then determine the length of the unitary chord that's used to define the shape model and derive the diameter, measure the diameter quite accurately. The process here is iterative in the sense of we combine our results with shape models to get diameters at astrometry, and then shape modelers use occultation results to improve their models. So it's we feed off each other. One of the things that we've learned from basic analysis of our results is that the diameters from the various satellites, such as Neowise, are in fact quite reliable across the spectrum. There are anomalies, which are almost certainly caused by odd albedos or reflections of a small number of asteroids. But the satellite diameters within their levels of uncertainty are pretty reasonable. Well, formal publication of our results. Fundamentally, it's almost non-existent. The monthly Notice of Royal Astronomical Society paper that we did a couple of years ago gave an indication of results, but nothing more. I'm preparing a PDS archive, which will have a full table of results for size and shape, or for the size, for asteroids with shape models. But we've been pretty hesitate to use the word pathetic, but we have not been good at publishing our measurements of size and shape of asteroids. We measure them, but we don't do anything more generally with the results. Some researchers have made use of our occultation results, retrieving data from the PDS archive, and they have been used in combination with mass measurements from which they've derived from the orbital perturbations of asteroids around the sun. But they have been used to derive densities of some asteroids, which was quite interesting. I think the reliability was fairly small because of the mass was hard to determine, but yeah, interesting. Now, this is I'll just refresh myself here. This is a new feature I've added into Occult quite recently, and I've put it in place there to as a basis for what I've included in the latest archive for planetary data system. This output gives the diameters as a weighted mean diameter of each asteroid as fitted to shape models. So we can see at the first one there, Julia, the diameter determinations from the satellites as a mean is 145 plus or minus 7. And here, this is one shape model fit. It's the diameter we've determined from our data here is 137, 137 plus or minus 3. That's derived from 7 events. And in fitting those events, the shape models, everything fitted nicely. And the model is Dammit 1805. There's a second Dammit model, and this one gives 140 plus or minus 2, again from 7 events, and all fitted nicely. So you got there 137 plus or minus 3, 140 plus or minus 2. Overall, they're both a bit smaller than the satellite diameters, but better uncertainty. If you take this one here, Aegina, 106 plus or minus 5.5. Here we have 102 plus or minus 2 from 9 events. None of things are invalid. Here we've got 102 plus or minus 1 kilometre. That's from a fit from 3 events, and 2 other events indicated that the model was invalid. So that solution there is unlikely to be a good solution, and that model is good reason to believe it's not a good, it's an unreliable model. So this is a table which you can now generate in Occult, which is actually giving diameter results from our observations. And we've never done this up until the last month or 2.
So, Dave,
Yep.
That's essentially a paper, isn't it? All we've got to do is write a blurb in front of it, and a blurb at the back of it, and then you know, get rid of some outliers, simplify, and that's a paper.
In broad terms, yes. I fear there's more to write in the paper than that, but I think it's something that
you and I can do.
Potentially. It's something we ought to be doing, and we've got to figure out where and the avenues. I mean, monthly notices was good because they didn't have a page charge. for submitting, but that's
But-
changed at the end of this year.
But
And
if,
I don't think that there's any publications that we have ready access to, which
Why-
would cost us.
why would we need to worry about money at all when IOTA America has got $500,000?
Ah, well, I mean, we can discuss this. Yeah, there's
cough up, boys.
well, yeah, that's a fundamental issue of we're getting these results. This is the data that asteroid occultations was originally promoted to achieve.
Yep.
And the reality is we've done stuff all to disseminate our results.
How much does it cost to publish in Nature?
Oh, your bank balance?
Yeah, but I'm not my bank balance. It's IOTA's bank balance.
Nature's not cheap.
Yeah.
I forget how much monthly notices. I think you're looking at $1,000 or more.
IOTA can afford that.
Yep. I mean, that's
Okay.
something which,
Yeah. All right. I'm only pulling people's legs, but let's do it.
yes, of course, this is going to be in the PDS data set. So in that sense, it's sort of published. But I think we
Yeah.
need to explore how we can have an ongoing, reliable place to publish these results and have them updated from time to time as we get more results.
But if we have a paper, then like then it can be cited and so on and so forth.
Exactly.
Right. Looking forward to it.
Astrometry. This is a much more positive area. The astrometry stuff came about when back in 2003, after the Sydney IAU conference, there was a meeting of the Minor Planets group up at, I forget the name of the place, up at
Nelson Bay.
Nelson Bay. Yeah.
First time I met you.
Oh, I don't remember you there.
Yeah, me and Graham were both there.
Yes, and I had been in Geneva the 2 weeks before and sort of flew into Sydney from Geneva and then drove straight up there. Missed the first day. So anyway, had a discussion with geez, my memory's going crap. Gareth Williams, who was the director at the time. He was interested in, I explained the possibility of doing astrometry, and he was interested in doing that. So over the next few years, developed a process with our first report putting in 2007. The processing arrangement was totally off stream. Gareth had written his own bit of software to do whatever he needed to do with our results to feed it into their system. And that was the case up until about 2019. At that stage, there were a number of things happened. We identified a need to do a serious review of the entire back file, and we did it multiple times, and develop a detailed error model. Spent a lot of time with the people at Horizons and a woman from Minor Planet Centre, developing a very complex error model, which gives very good results. And then the Minor Planet Centre was implementing new systems. Gareth Williams retired, and his private little way of handling the stuff sort of was non-functional. The IAU implemented a new thing called ADES, the Astrometry Data Exchange Standard. And when we started working through what was involved in that, there were a couple of provisions in AIDS which had to be revised with new codes and stuff provided to accommodate the high accuracy available with some of our observations. For example, the ability to, with optical observations, to refer our astrometry to the center of mass of the asteroid rather than center of figure or center of illumination. That wasn't provided there. They had a provision for radar observations to do that type of thing, but not for optical. So they had to do that. They incorporated UBSC as a reference catalogue. There's been a number of things they've put in place specifically for our occultation observations. We have a new observatory code, 275. Reporting's now recommenced. I sent off a report in April. Minor Planet Centre still hasn't implemented aids as much as is needed. They're they're supposedly working on it. Once it's in place, then their reporting will become routine reporting every few months, sending off a batch of astrometry. Yeah. The other thing with the astrometric side is with special events such as the Didymos Diphobus event, Phaethon, a couple of others. We have a good working relationship with the JPL Horizons people, and we can send results direct to them, and they'll update the orbit for us. So just the other day, we got some astrometry for Chiron, 2060 Chiron, from 3 events since 2018. We put them into our system, and I sent off the astrometer horizons, and the key person's on holidays at the moment. We'll be back on the 18th, and they'll update their orbit for us. Similarly, recently with the Betelgeuse occultation in December, we noticed that latest prediction, their latest orbit had shifted the path significantly south of where it was previously predicted. So we got directly onto Horizons, what's going on here, and they looked into it and found the cause, which was part of their update processing, and improved the orbit. So we've got good working relationships with the key people involved with astrometry. Base of our astrometry, star casts shadow of the asteroid on a plane which goes through the center of the Earth and is normal to the direction of the star. I've taken this from an eclipse, but an asteroidal occultation is an eclipse of the star by the asteroid. The mathematics are identical. If you're located at that point, the asteroid has the same position as that of the star, the same apparent position, because it's got issues of gravitational deflection by the sun floats in there somewhere. And the astrometry that we report is an event time and the location of the center there where the axis hits that plane. That's an XYZ coordinate of that point, where we have observed the star being coincidental with the apparent position of the asteroid being coincident with the apparent position of the star. The report process is exactly the same as what happens when they do astrometry from an satellite orbiting around the Earth or the sun. Our process, it's exactly the same, except our satellite's orbiting around the inside of the Earth. One of the interesting things in this process, and indication of the type of precision we're dealing with, you observe a time here of whatever time it is. The reduction is done down here. A small amount of time is added to your event time to allow for the light time, for the light to go from there to this plane. We're really at a very fine level of precision there. This is just an example of the report that gets generated. Starts off with some bibliographic data there. It has measures, which are the regional coordinated people. Have a list of all the observers involved with the observations, because the observers get, as far as I'm aware, included in the ADS system, astronomical data system run by somebody for all astronomical papers and stuff. So all the names get reported following on publication by the Minor Planet Centre. And this is the report. It's the object. It's an occultation observed at that station. Here's a time, RA and declination of the star at the J2000 type position. They're both 0. That's coordinate system stuff. Here's the X, Y, Z coordinates that we report. That's the critical bit. Uncertainties and a correlation there. Catalogue here. That event there. That astrometry has been reported as relevant to the centre of mass of the asteroid. Same with that one. And here there's just general uncertainty comments there. I won't spend time on this. This is the error model. It's complex, but it covers a whole raft of situations. Single chords and multiple chords, whether or not you got a shape model, a raft of issues in there. It's explained in the help file of Occult. It's included in the file format for asteroidal occultation observations. Now, this is an illustration. I'm sure you all appreciate we're getting good results, but this I wanted to show just how good we are getting. This is for Didymos, which we didn't have a success in Didymos. These circles represent the position. Here's the large circle, the center there. That's the position of the astrometry report with the uncertainty. And as things went along, our uncertainties got better and better. It depended a bit on the number of chords. And when you look at all this, you find that the center of all that is all around there. What's the scale here? That's a scale in milliarc seconds. We're talking about an uncertainty there of plus or minus a milliarc second. And same there. The next slide, this slide is perhaps even more illustrative of what's how fantastic our results are. This is the results of the fit and the uncertainties of the various techniques. This big blue circle is the uncertainty of the orbit solution prior to the DART mission impact. It was done in August last year. Quite large. The scale here is kilometres. Subsequently, they added radar measurements, and that provides the uncertainty from there, still large. Then you have the DART mission itself, when it's right next to the thing, and it's got its operational navigation systems reporting data to the Earth. You add that in, and that's the uncertainty ellipse for that. And hey, that's the uncertainty from the satellite, which was there. And then you take our occultation results, and that's that little purple circle in there. 14 occultations, and our uncertainty is so much smaller than any of the other techniques. It's rather incredible how accurate our technique can be. And hey, some of these other ones cost bucket loads of money, and us as a bunch of amateurs getting the best astrometry of all. So double star discoveries, as I indicated before, we ought to be doing more with double stars. They're proper discoveries. Brian Loader did a really good job on that, but life moves on in terms of age, and the current situation where we've got a bit of a black hole of what happens. We need to have a paper published in the Journal of Double Star Observations. That is the path required by US Nova Observatory, who manages the catalogues. They do not want or accept data being submitted to them. It's got to be published, and this Journal of Double Star Observations is their recommended source, and they're quite easy to work with. The observed data required is light curves, star identification, magnitudes and coordinates, asteroid identifier, date, and a little bit of blurb to fill in the spaces. You need the computed double star solutions, and assistance may be required for there. Observers have most of the information, and my basic feeling is we should be able to put together a pro forma paper that would enable observers to easily prepare the paper that's required. So basically, a Word document or something where, hey, put your light curve in here, put your star details in here, and put your location and name here, and add a few more words of no great substance, and you've got a paper. I'd expect that the observers will need help with the double star solution, but the rest of it should be straightforward. The issue here is the regional coordinators don't have the spare time to do it. And I would hope that observers will be in a position to do it. So my proposal, which I need to keep on to push along, is somebody, maybe Dave Galt and myself, good on you, Dave, does the work to create a pro forma paper. Probably need to be a couple of versions. Observers who discover something use the pro forma paper to and put their data into the paper. Coordinator provide assistance with the solution. Paper just a review by the coordinators, so we've got a quality control process, and then submit the paper. Should be very simple to do, and put our double star discoveries in a proper footing. Now, I think getting close to the end, the final bit is our data. We've got this massive database now. There's over 8,800 separate occultation events in our database. Our data is archived with NASA's planetary data system. Dave Dunham originally organised this back in the about 20 years ago. It's been paused for several years for the same reason as the astrometry. The next archive, I'm planning on sending it off in the next day or two. It's all effectively finished. In processing the archive, there's a huge amount of work needed. There's got to be a description for every field in the archive. And the archive is basically all data elements in their occultation observations file. Each event has 260 columns of data, which is a huge amount of data. For each observer that makes an observation, there are 42 columns of data. With 36,000 rows, that's, you've got 1.5 million observer data items, 2.2 million event data items. And each column required to have a full description of its content. This is an illustration of the archive data in a fairly crude viewer. The columns you can see across the top, there's the date of the observation, there's a reference hour, star catalogue, star number, the Gaia version, the Gaia star number, the star array, and it keeps on going to the right for another 250 odd columns. And then you put the cursor on this thing over a star catalogue, and here's the detailed text that comes up to explain what's included in the star catalogue. And all that information I had to manually create. Once it's created, each time we do the archive, very rarely will any of these need to be updated. But it's a fair bit of work to set up the archive. And the archive files that we've got give the observations, events and the observer details, the diameters from shape model fitting, the astrometry, and all the double star solutions. And after all that, that's it from me. I'll take questions. Any questions, or am I not hearing something?
I think there was someone wrote something in the chat.
Yeah, I think we know the balance of Dave Galt's bank account.
That's Tony's. That's Tony's estimate anyway.
Yeah, the publishing in professional journals, monthly notice was good because it didn't cost. Provided it stayed under 20 pages, didn't cost anything. We went to 20. We went a bit over the 20 pages, and there was a charge of £50 or £100 for the extra page. But now that monthly notices has putting in page charges, that's a problem. If we were European, astronomy and astrophysics would be free, but you've got to be European. So perhaps Jerry can take on that role. Um,
I'm actually a Maltese citizen. I don't know if that counts.
yes, it's Journal of Occultation Astronomy is a possible path, but I prefer something more mainstream than that. I mean, we're doing professional quality work, and we need to tap into where the professionals get their info. And just how we achieve that, I'm not quite sure. But anyway, that's hopefully gives you a better idea of what happens to your data and what's not happening and what should happen.
No, very good. Thank you for that, Dave.
I should add in all this, in all the processing, I and Dave Goltz take a fairly strong view that quality assurance is a critical component of our reliability. When you look at the results from Didymus and the type of accuracy we're achieving there, the professionals involved in that have been hugely impressed by the data that we've been providing. I mean, it's better than anything that they can do with their professional systems. We have built up a reputation of producing reliable results. And that's in part because we have a process where if results look iffy, we challenge them. We don't take the observer's assessment, oh, I am sure this happened. How dare you challenge me? There was a couple of observers years ago in Baja, California, where I well remember them. They're both passed on now. But there was no way you could question them, raise any questions about their observations. They would go ballistic if you merely queried it. Now, there are other observers, we still have observers around who, how would you describe them, Dave? Cause us a bit of grief? Unmute yourself.
Right. Yeah, they're a bit recalcitrant. Yeah.
Yes, we sometimes have some discussions which at times get a little heated. But I view that as an important part of quality assurance, so that when people get to use the data, they know that the data is in fact reliable, and that we're not accepting just anything because an observer says, hey, this is it, I saw it, never mind. We've got rigorous processes in place. And I mean, Dave Galt and myself are at the very pointy end of that. All the regional coordinators have a role in there. And it's something I guess everybody needs to be aware of. As to when we do ask questions, it's because we want to ensure that our credibility in our observations remains very high.
Great. Mm-hmm. Okay, what's next, Steve?
Next was just a bit of open mic, which I think we probably had a little bit earlier on our